In this second lesson on flight mechanics, we examine the relationship of the forces in a straight, steady climb. As in straight and level flight, the forces are lift, normal to the flight path, thrust and drag, parallel to it, and weight, parallel to the force of gravity. With the aircraft in a climb at an angle to the horizontal, the Greek letter gamma denoting the climb angle, the weight vector is inclined backwards relative to the flight path at the same angle as the climb flight path is to the horizontal. Note that the JAA objectives use the Greek theta instead of gamma for the climb angle. Weight, W, can be resolved into two components, one opposing lift with a value of W times cosine gamma, and the other acting in the same direction as drag with the value of W times sine gamma. This backwards component of weight, when added to the drag, creates a requirement for more thrust to re-establish equilibrium for steady flight. In a straight steady climb, lift is less than weight, because lift only has to support a proportion of the weight, with the proportion decreasing as climb angle increases. The remaining proportion of weight is supported by thrust. The ultimate illustration of this would be a vertical climb, where no lift is required, but lots of thrust is. You can see that, for a straight steady climb, the thrust required is greater than the drag, because the backward component of weight is added to the drag force. The ability of an aircraft to climb depends on the excess thrust available after opposing aerodynamic drag. The smaller the drag for a given thrust, the greater the ability to climb. For example, drag is less with flaps up, giving a larger climb angle or climb gradient. The climb angle achievable depends on excess thrust, thrust minus drag, and the weight. As both drag and thrust vary with IAS, the excess thrust will be greatest at one particular speed. This is the speed for the best angle of climb, known as Vx. This graph shows the variation of thrust with speed for a jet aircraft, where thrust is fairly constant with speed. And Vx is close to or coincident with Vmd. With a propeller-driven aircraft, where thrust decreases with speed, the maximum difference will usually occur at a speed below Vmd. The drag produced by an aircraft at a given IAS is not affected by altitude or temperature, but higher weights will increase drag, thus reducing the excess thrust available. Climb angle will therefore decrease with increasing weight. Increases in both altitude and temperature will cause a reduction in the thrust available from the engine or engines, which also reduces excess thrust. Climb angle will therefore reduce with increasing weight, altitude and temperature.